All right, it's almost the end of this module. National Math and Science Initiative, Physics 2, Training Through the Internet. Part C, we're going to do some labs on magnetism. And I'm just going to say this right now. If you look at these labs and say this is too much for you, I understand. You may cut up this video and show parts of it with the lab parts to your students and then give them the data that I took or something like it. I don't know. But if you're not going to do these labs in real life, and I encourage you to if you could, you may modify this video for your students and then give them the data. Don't give them the graphs though, and don't tell them the analysis part either. Make them do all that stuff. You know who I am. All right, remember, I'm not telling you all of the learning objectives, just the ones related to the labs I'm about to tell you. Students got to relate to the force acting on a straight wire to the wire's current and the wire's magnetic field and the length of the length of the wire and the magnetic field. In other words, F equals ILB. Students have to understand the F equals ILB equation. So to do what I call the magnetic field in the box lab, which is what we're about to do, the magnetic field in the box lab, you'll need a very serious battery. I use a car battery or the riding lawnmower battery. Very low value resistors. Mine are 1 ohm and can withstand 100 watts. Those are expensive. I mean, they're a couple of dollars each, but you're not buying more than 6 of them for this. Lots of alligator clips because I put my 1 ohm resistors in parallel. So each one requires 2 alligator clips. Ammeters, my ammeter can take 15 amps of punishment. The ones from Harbor Freight Tools I've been telling you about have a special plug for 10 amps. And boy, you be careful because more than 10 amps and that fuse will blow. We need some pretty sensitive scales. I had some that went to 0.01 grams. Our chemistry people have 0.1 gram sensitivity. 0.1 gram sensitivity, good enough. 1 gram sensitivity, not good enough. Sorry, folks. Can't be steel. It can be aluminum, it can be copper. Cannot be steel because it would stick to the magnets. And you saw me construct the magnetic field box in part B. Or not the magnetic field box. Maybe you can use a horseshoe magnet, just something strong magnet, okay? All right, here's the purpose of the lab. Measure the magnetic field inside the box or in between the parts of the horseshoe or whatever you want to say. So what are we going to do? We're going to place the aluminum rod through the magnetic field box, and the supports for the rod are going to be the 2 scales. So the 2 ends of the rods are going to sit on the 2 scales, and the rod is going to go through the magnetic field box. The aluminum rod is going to be part of a circuit that consists of the rod, ammeter, and batteries are all in series. And the resistors that I'm going to put in parallel, but you can put them in series or parallel. You just have to change the resistance. Change the resistance or the current on each trial, essentially. We're going to change the number of resistors to change the current. We're going to use the readings on the 2 scales to get the magnetic force on the rod. And we're going to take several trials of different amounts of current changed by the resistors and the amount of force that the magnetism exerts. Okay, well, I guess now's the part where we actually try it. Let me show it to you.